Hello everyone. Today we are going to start with organic chemistry. Why organic chemistry is so special? Because it is made up of only few elements. Entire organic chemistry you can fill it with carbon, nitrogen, hydrogen, oxygen, sulfur. Using these five elements, you can cover up to most of the organic compounds, right? Out of this, the most interesting and our hero, that is carbon. We'll talk about carbon in a while. Before that, I would like to tell you about organic chemistry. What is that? What are organic compounds? So first, about 200 years ago, people were thinking that organic compounds are the one which is from animals and plants. In case of inorganic compounds, they are from mineral sources. People were thinking like that. But there was a chemist called F. Oher. In the year of 1828, he synthesized the first organic compound. Have you ever wondered, we are having so many compounds in our textbook, our reference books. What will be the first organic compound ever synthesized? That is none other than urea. F. Oher synthesized urea from an inorganic compound, that is ammonium cyanate. The formula of urea is NH2CONH2. This is the first ever synthesized organic compounds. Okay, after that they started working upon with methane, acetic acid, and etc. Okay, but why carbon is so special? Why carbon is having a property to form an entire branch in chemistry? For that, I would like to tell you the important property of carbon, that is catenation. In the entire periodic table, out of other elements, carbon is having this catenation property. What is this, ma'am? This is the tendency of self-linkage. What is that? Tendency of self-linkage means carbon can bind up to another carbon, and another carbon, and so on. It can extend to form long chains and rings. Carbon shows maximum catenation property out of other elements in the periodic table. It can combine with other atom also, or carbon can combine with another carbon through single bond, double bond, and triple bond. Okay. Any other element is having that property? Yes. The next two carbons, silicon, I'm talking about in row wise. So silicon, atomic number 14, that is also having the catenation property, but not as good as carbon. It is very short, but carbon can form in number of bondages with other carbon. Okay, that makes carbon so special. Each one of the elements should have some identity, right? Okay, you say carbon can form bonds with other carbon. But how many bonds it can form? One carbon can form how many bonds? Carbon can form 4 bonds. How? How the valency of carbon becomes tetravalency? What is tetravalency? The valency of carbon is 4. How that happens? What about other elements? Let's see. For that, we must know about the electronic configuration of carbon. That is 1s2, 2s2, 2p6. 2p2. Correct. If you are not aware of how to write these electronic configurations, please let me know in the comments. We will create a short trick video for this. Okay. Coming back to the topic. Here I have 2 in the first shell, 4 in the second shell, that is the outermost shell. So let's draw these electrons. 1s, 2s and 2p2. Okay, so this is the ground state configuration of carbon. What is this ground state, ma'am? Ground state is like the normal state without any disturbances, without any interference of other atoms towards the carbon. But what happens if some other nuclei is approaching carbon? Before that, tell me, what will you do if your friends or the guests or your relatives are coming to your house for staying? You will do the accommodation. You will make up the bed, create some space for their stay, right? Similarly, the atoms also behave like that under one condition. Each room, these boxes should contain carbon electron also, then another electron of other atom can form and share that space, right? For example, let's say another carbon, or let's say hydrogen, the simplest atom, right? Hydrogen is coming towards carbon atom. Okay, so carbon will get excited state. So in that case, what will happen? 1s, that is the inner shell, that remains intact. What about 2s and 2p? The one electron of 2s will get excited to 2p, so that now the configuration becomes 2s is having 1 and 2p is having 3. If I want to fill up these spaces, how many electrons it need to reach the stability, or how many electrons it need to become a neon gas configuration? It requires 4 electrons. So those 4 electrons will be given by the incoming atom. The sharing will happen. So remember, entire organic chemistry or most of the organic compounds is made up of covalent bonding. What is covalent bonding? It is a sharing of electrons. Each bond will consist of 2 electrons, one from one atom, another electron from another atom. That's quite a sharing. Okay. So that makes carbon is having tetravalency. What about oxygen? What about nitrogen? What about sulfur? What about hydrogen? Okay. You can work on those elements. Now I'm going to give you the numbers only. For example, hydrogen, the valency is 1. Oxygen, 2. What I mentioned, valency here, that is, it can form up to that many bonds. Not up to, like, it should form that many bonds to be neutral, to remain as neutral. So nitrogen, 3. Okay, you can remember it like HONC, which stands for 1, 2, 3 and 4. Honk. hydrocarbon. By the name indicates that is having only carbon and hydrogens. So most important hydrocarbons are actually 4. First I like to tell you the first 3, that is alkanes, alkenes and alkynes. What are these? What is the difference of these 3 hydrocarbons? The first one, which is saturated one, other 2 are unsaturated. That is the major difference. What is saturated and what is unsaturated? In the oil packets, in the advertisement of oils or some other food elements, you can see saturated fatty acids or unsaturated fatty acids. Right? What are that? What is that? We'll see. First of all, let's understand what are these 3 categories: alkanes and alkenes and alkynes. These are having the general formula of 2n H2n plus 2. For example, if I am giving n is equal to 1, then the formula becomes C1 H 2 into 1 2 plus 2 4. So CH4 it becomes. If n is equal to 2, then it is C2 H6 and so on. You can substitute it up to any number. Similarly, in case of alkenes, it is having CnH2n, where n is equal to 1, 2, 3, 4 and etc. Then the first, if I am substituting 1, what will happen? If I am substituting 1 in case of alkenes, what will happen? C1H2. But that is not possible. Carbon should have 4 bonds, right? So this is not possible. It should start with 2 carbon system. So C2H4, that is the first alkene. For alkynes, the formula is CnH2n minus 2, where the n starts from 2. So it becomes C2H2. Okay, so here you can see the number of hydrogens are getting decreased. So what will happen to the bonds? In case of alkanes, it will have only single bond or only sigma bonds. But in case of alkenes, it can have single and double bonds, pi bonds as well, right? Double bonds or pi bonds. The single and double bonds are allowed. In case of alkynes, single and triple bond. Okay, so these are the main differences between these 3. We'll see about these alkanes, alkenes and alkynes in the upcoming video in detail, how to prepare it, what are the bonds involved there and what else it can do. We'll see there. Now let's move on to how we can write the organic compounds. What are the ways to write the organic compounds? Okay, so now the representation. First, I can write it through molecular formula. like IZCH4, C2H6 or C2H2. Okay, so those are molecular formulas. And second thing is structural formula. Structural formula can be classified into two, that is expanded one and condensed one. For example, expanded one for methane is, that is CH4 is, I just have to write each of those bonds, right? In case of condensed, let's say I'm taking two carbon system, that works better. So in that case, I have to write it as CH3, CH3. If I want to write the expanded form of C2H6, then I should write it as, again, one CH3 with expanded one. Okay. Other than this, we have another representation, that is bond line. Bond line formula. What is that? Here you can see, would like to take that for 3 carbon system. For example, if I'm having C3 of alkane, so which makes it H8. So 1, 2, 3. So this is the bond line formula of C3H8, which represents each of these corners are having carbon and remaining hydrogen parts are understood. Hydrogens will not be represented here, but you have to understand that. Like you can see the first one, let me do that in different color. So the pink one is one carbon and blue one is in another carbon, green one is another carbon. Okay. In that case, the pink one is attached with blue carbon. So remaining 3 bonds are left. So those will be hydrogen. Okay. So this is CH3 and blue one. Blue one is having 2 bonds with pink and green. So remaining 2 hydrogens must be there. That is CH2. The same thing for green one as pink, it becomes CH3. Okay. So this form, I just written it here as bond line formula. I'm sure if that is confusing for now, but end of this organic chemistry series, you will be master in writing these formulas and reactions, mechanisms and everything. Okay. So don't get scared. We'll go step by step with detailed explanation. So if you have any doubts at any time, please tell me in the comments. Okay. Of organic compounds. Major classifications. This is broadly classified into acyclic and cyclic. Acyclic is further classified into straight chain and branched chain. Cyclic is classified into aromatic and alicyclic. Okay, so what are these? By the name represents, acyclic is not having any closed system like a ring. It can be starting from 3 carbon system. Okay, like this. So it should have, cyclic means it should have a closed system of carbons. Acyclic means there is no closed system, there is no rings. But in case of cyclic, that will have the closed system. Okay. So acyclic straight chains. Then it will have the representation like this without any interfering of other carbons. But in case of branched, you can see some other groups will get attached over here. Okay, these are branches. It is branched chain of acyclic. What about cyclic? In cyclic, we have aromatic and alicyclic. Aromatic are the one which can be classified into 3. One is benzenoid. The cyclic structure which is made up of only benzenes, or non-benzenoids, and finally heterocyclic. So benzene will have carbons only, carbon and hydrogens. Non-benzenoid, that is not having the benzene structure. But in the case of heterocyclic, it will have other atoms as well. It can have nitrogen, it can have sulfur, for example thiophene, for example pyridine. They are aromatic heterocyclic compound. Similarly, alicyclic will have 2 classifications, that is homocyclic and heterocyclic. Homo means same atom will be there. Hetero means different atoms will be there. Okay.